Hello everyone. Today I'm going to be presenting about quantum computing. Firstly, I would like to give a quick brief on why we need a quantum computer. As we all know, classical computers are made up of transistors which act like switches. Over a brief period of time, they have shrunk in size in order to provide us mobility and solve complex problems. Today, a typical scale for a transistor is 14 nanometers, which is about 8 times less than the HIV virus diameter and 500 times smaller than the red blood cell. As transistors are shifting to a size of only a few atoms, electrons may transfer them to the other side of the block passage via a process called quantum tunneling. This leads to the physical limitation of this technology, and this is where the quantum computer comes in. So in order to understand what quantum computer is, we first have to understand superposition and entanglement. The superposition is a state referred for qubits. Qubits are the quantum bits used in quantum computing, just like bits are used in a classical computer. The superposition state of qubits allow them to range between 0 and 1, unlike the classical computer bits, which are either 0 or 1. Entanglement. It is a property where there is a connection between each qubit. That means when you make a change in one qubit, it has effects on others. This property expresses a high correlation between two or more qubits, allowing it to compute different possibilities at the same time. A quantum gate is similar to a logic gate. It manipulates the superpositions, rotates possibilities, and produces another superposition as its output. With the help of this, a quantum computer applies quantum gates on qubits to entangle them and manipulate possibilities. When you implement these phenomena of quantum mechanics to perform a computation, then it is known as quantum computing. By cleverly exploiting superposition and entanglement, you can exponentially increase efficiency that would ever be possible on a normal computer. Some of the use cases of quantum computing are improved security through quantum cryptography, solving complex mathematical problems through quantum computations, searching through big heaps of data in no time through quantum search, and etc. Even though quantum computers can prove to be very efficient, it won't be replacing classical computers. Applications of a quantum computer is going to be mainly focused onto the task that a classical computer cannot perform efficiently. It has the potential of being used in cryptography for better and improved security, healthcare for discovering new vaccines for targeted cures, financial for computing risk and also for investment predictions of a stock market, travel for self-driving autonomous cars, artificial intelligence for being more effective and efficient, weather forecasting and climate changes for providing more accurate and precise data. These are some applications that currently require a lot of computation power to give results, but quantum computer is going to change that. As for the maturity of this technology, according to the Gartner Hype Cycle 2005, the technology was still around innovation trigger. It has been there for more than 10 years. According to an analysis by Nature, quantum computing has been termed as the gold rush. In 2012, around 52 companies focusing on this technology have been backed by the private investors. In 2017 and 2018, companies received $450 million in funding from private investors, more than 4 times the funding from previous 2 years. To sum it up, theoretical potential of this technology is sufficient to suggest the importance of it. I hope this presentation helped you understand what quantum computing is and its applications. Thank you for watching.